So welcome everyone to tonight's event. For anyone who doesn't know who I am, oh my Lord, that picture. Thank you, Jerry. And so you can see me up here. This is like the less beautified version here. So I'm the Federation of Astronomical Societies International Liaison Officer. So my job is to help link FAS and its member societies internationally. So if you ever want to do something with international societies, come and talk to me. And so I'm especially happy, of course, to have an international speaker tonight as well. It's good to see so many people here. So like I said, we do literally have people from all across the country. I know as well, though, that some of you are actually not members of societies. So for anyone, I was going to point, Jerry shared a slide, so I was going to point at the URL, which is here, you can't see it. So if you want to join a society, you can come to this website. Just go to the society section and you'll be able to find societies near you. And you don't need a telescope or anything like that. But if you join the member society, as well as the benefits of that, you'll also get the benefits of being a member of FAS, which means you get 50% off events like this, and also off our yearly conventions. So we do an annual one-day convention. It was at the Institute of Astronomy, Cambridge, this year. Next year, we're going to be in Cardiff, and we're looking at Edinburgh for the year after. So hopefully we will be somewhere near you, and it would be great to meet you all in person. Now, as you know, tonight, we do have two talks. So we have the main event with our special guest, Professor Mike Brown. Hello, Mike. And also a short introductory talk from our very own Jerry Stone. So most of you probably already know Jerry very well. He's been presenting space topics across the UK and internationally for over 50 years now, which is hard to imagine, but it's true. He's an acknowledged expert on various aspects of astronomy, space exploration. He runs Spaceflight UK. He's a freelance space presenter, broadcaster, and author. And today he's going to whet our appetites with an introduction to the solar system and the discovery of planets. And as I said, if you do have any questions during Jerry's talk or for Mike's talk later, if you can enter those in the chat window, that would be great. What would be super helpful is if you put a question in the chat window, please put a Q at the beginning, like a capital Q. And it just makes it much easier for us to then spot the questions among the general chat. But I think that's all I need to say. So over to you, Jerry.
Thanks very much. And that 50 years is not a typo. It's actually more than 55 years, because I gave my very first space talk when I was at school, when I was 14, back in 1969. Now I do it for a living. So we're going to start thousands of years ago, when people looked up at the night sky and they saw the patterns of stars, and they noticed that from night to night the patterns moved slightly, but the stars kept the same position as each other. But there were some dots which moved across the sky, as you can see just upwards of the centre. And the Greek astronomers noticed these things wandering around the sky, so they called them wanderers. Except, of course, they didn't, because they spoke Greek and not English. And the words they used was planetol, which is how we get the word planets. And there were 5 of these that could be seen with the naked eye. So moving outwards from the sun, we have Mercury, Venus, the Earth, Mars, Jupiter, and Saturn. And then with the discovery of the telescope, which could see fainter things, in 1787 we discovered Uranus. And the next planet to be discovered after that was not Neptune. So you notice that I've shown a large gap between Mars and Jupiter, and there is physically a very large gap. And knowing the relative distances of the planets, it was thought that there ought to be a planet in that position. And so a search was made by a group which came to be referred to as the Planet Police. but they were actually jumped by Giuseppe Piazzi on the very first day of the 19th century, that is the 1st of January 1801. The century did not begin with 1800, just like the 20th century didn't begin with 1900, and the 21st century and the new millennium did not begin in the year 2000, despite what was said on, of all places, the website for the Royal Observatory at Greenwich. Anyway, on the 1st of January 1801, this object was discovered. But what was unexpected was that about 2.5 years later, another similar object at a similar distance was also discovered, and then a third and a fourth, and these were Ceres, Pallas, Juno and Vesta. And at the time they were listed in tables and in books as planets. But then as more and more were discovered, it became obvious that they couldn't all be planets in the generally accepted meaning. And it was William Herschel, who had discovered Uranus, who came up with the term asteroid, which means star-like, because these were small objects, and even through a telescope at that time, points of light rather than showing disks like the others. So the solar system was changed from 11 planets down to 7 until the following year, when the next real planet was discovered. Now this was because the orbit of Uranus was not following the path that was predicted, and it was assumed that there was another planet whose gravity was affecting it. And so a search was made, and Neptune was discovered within 1 degree of the position calculated in the night sky. So Uranus was discovered by accident. Neptune was the first planet to be discovered as the result of a deliberate search. And that's how the solar system stayed for around 70 years, when the orbits of both Neptune and Uranus were again found to be subject to some discrepancy. And so it was assumed a further planet existed. And in America, the task for finding this was given to Clyde Tombaugh, seen with one of his personal telescopes. But he actually worked at the Lowell Observatory in Flagstaff, Arizona, and this is what he used. Now, the big difference was that not only was he using a telescope, but a telescope fitted with a camera. So what he would do is take photos of areas and then take photos of the same areas a few days later and compare them to see if anything had moved. So today, this would be done by a computer, scanning the images and comparing the positions of all the dots. But 95 years ago, this had to be done manually. And he used a blink comparator, which held the glass plates, which were 17 inches by 14 inches high, and he slowly moved across them, comparing them, flicking back and forth. So here are 2 pictures that he took on the 23rd and 29th of January 1930, and he spotted this, which in the second picture was not there, but there was a spot here which was not in the first picture. And by knowing the angular distance that it had covered and the time taken, its orbit could be calculated, and it was found that it was way beyond Neptune. So if we compare them here, you can see the difference. So this made headlines in the newspapers in America and in England. And this is Venetia Burney, who at the time was 11 years old. And on the 14th of March 1930, she was at home in Oxford having breakfast with her mother and her grandfather, Falconer Madden, who had previously been the librarian at the Bodleian Library at Oxford University. And on page 14, he read the news of this discovery of a new planet. And he said, "I wonder what it'll be called." Well, Venetia knew about the Greek and Roman gods, and she knew the names of all the existing planets. So after a few moments, she said, "Why not call it Pluto, the name of the god of the underworld," which seemed appropriate for an object in the far reaches of the outer solar system where it would be very cold indeed. And her grandfather thought that was an excellent idea. So he passed it to Herbert Hall Turner at the university, who had previously been the Astronomer Royal, and he sent a telegram to the Lowell Observatory in America. Now, when I tell this story in schools, I explain that a telegram is an early form of text message. So they discussed it and unanimously agreed that Pluto was the perfect name. And the word came back to Oxford, to Falconer, who told Venetia that her suggestion had been adopted. And to say well done, he gave her £5. That was in 1930. That's the equivalent today of about £400. He liked to be generous. So, more headlines, and Pluto not only had a name, but a new way of describing it in astronomical terms, using the initials PL, which were the first two letters of Pluto, but also the initials of Percival Lowell. We had a solar system with the Sun and 9 planets. Now, if you were a geek like me, you could remember the name of all of them, but one way of remembering them was to use a mnemonic. You take the first letters of the names of each planet and make a sentence of words that start with those letters, such as, "My very easy method just speeds up naming planets," or "Many vicious elephants munch jam sandwiches, unusually no peanuts," or one which I made up for Valentine's Day, "Mary's violet eyes make John sit up nights pining." Then there's one that you shouldn't use in schools. "Mary's virgin explanation made Joseph suspect upstairs neighbour Peter." But one that goes down very well in schools, one of my favourites, "My very excited mouse jumped straight up Nanny's pants." But the one that I've always liked is this: "My very educated mother just served up 9 planets." Perfect, does exactly what it says on the tin. But of course it only works whilst there are 9 planets. And that's no longer the case. So after the beginning of the new millennium, various other objects were found. So here's some of them on the bottom row, together with some more familiar ones above. And the one I want you to notice is in the bottom right, 2003 UB313, which of course is not its name. It's a designation saying when it was discovered. But look at its size. This was originally reckoned to be larger than Pluto. We now believe it's actually slightly smaller, but has more mass than Pluto. But the question was, surely if Pluto is a planet, this should be a planet as well. And what about the other objects? Shouldn't they be planets? Well, to answer that, you need to know what a planet is. And amazingly, up until then, there was no official definition of a planet. Now, I remember, as I'm sure many of you do, reading in books when I was very young that we can see stars because they give out light, but planets are only seen because they reflect light. But as I said, there was no official definition. So this was a topic discussed by the IAU, which is a worldwide organization composed of about 13,000 professional astronomers. And every 3 years they hold a major congress, and in 2006 it was in Prague. And this was debated. So the proposal was that the solar system of these original planets plus Ceres, the largest of the asteroid, and I'll explain that, and also 2003 UB313. Now, why Ceres? Well, we'll come to that in a moment, but Mike Brown, who led the team that discovered 2003 UB313, got so fed up of having to say that before it was given a proper name, he came up with a nickname, Xena. And yes, it was named after the warrior princess from the TV series, which should come as no surprise because, of course, astronomers are known for observing heavenly bodies. Anyway, so forward the conference, and this definition read, a planet is a celestial body that is in orbit around the sun and is not a star nor a satellite of a planet. And it has sufficient mass for its self-gravity to overcome rigid body forces, so it assumes a hydrostatic equilibrium. That means it will have a nearly round shape. And the third criterion was that it has cleared the neighbourhood around its orbit. So if an object meets the first two criteria, but not the third, and in the case of Ceres there are thousands of asteroids, then it will not be a main planet. But there's a new classification of dwarf planet. So here's a vote being taken, and this is what we finished up with. And since then, two other dwarf planets were accepted, Haumea and Makemake, also discovered by Mike Brown's teams. So, in fact, there are so many other potential dwarf planets that Mike produced a diagram showing the old solar system and the new one. In fact, his website has a list of possible dwarf planets in different categories. So apart from the 8 main planets, there are 10 which are nearly certainly dwarf planets, giving us a total of 18, plus 17 which are highly likely to be dwarf planets, 41 which are likely, 62 which are probably dwarf planets, and hold your breath, 611 which are possibly dwarf planets, giving us a total of 749, which is going to need a very long mnemonic. So I wonder how many of you know that a sixth dwarf did 2015 R245, and this shows its motion against background stars. And here's its orbit, which, as you can see, is very large indeed. And then another was announced only earlier this year, just a few months ago. So originally announced 2000, discovered 2017. So if you add those to the others that we already had, plus Quaoar, which I mentioned earlier, which is also listed by the IAU as a dwarf planet, we have 8 dwarf planets, together with the 8 main planets. So these are the main objects making up our solar system. So that means, as Mike and a colleague at the California Institute of Technology has suggested, that there is probably another main planet, which will be planet 9. So over to Mike, or rather I'll introduce Mike, who will tell us more about it. So Mike is, as I said, from the California Institute of Technology, and he has led teams that have discovered around 30 objects beyond Pluto. So he is the ideal person to discuss the search for Planet 9, and I'm really, really pleased that he has agreed to do so with us today. So over to you, Mike. Mike, are you still muted?
Have to find that button. There we go.
That's it.
Okay. Thank you for that nice introduction, and for the brief history of finding planets in our solar system. I'm going to actually go back and cover some of those same things in a little more detail. So after all this, you'll have your whole history of the solar system and discovery figured out. I like to go back to the year 1780. If it were the year 1780 and you were to go outside at night and it's California and the sky is always clear and it's beautiful outside, you look up in the sky, you could see every known planet. You could see Mercury if you knew where to find Mercury low in the sky. Venus is always easy to find. The Earth, it's right there, often easy to find too. Mars, Jupiter, Saturn, and that's it. Those are the planets that were known in 1780. And as far as I can tell, in 1780 and before, there was no discussion of finding new planets. You know, the telescope had been used to study the sky for a long time now, and there were moons around Jupiter, rings of Saturn, new stars in the sky, new craters on the moon. But nobody wrote anything, at least, that suggested that they thought maybe there might be new planets in the solar system. People may have thought about it and people may have discussed it, but I have not been able to find anything written down about it. So it seemed like an idea that just didn't occur to people, that there might be more planets. The planets were the things you could see. How could there be more of them? So in 1781, William Herschel had built what was at the time the very best telescope in the world. And he was using it to study the locations of stars. He was trying to map out the stars in the Milky Way to try to understand our own galaxy. And he would do it. He would look through his telescope and draw the positions on a piece of paper. And one night he was looking and he found something that was a little bit fuzzy. It wasn't very star-like. And he made a note of it on his piece of paper. He didn't know what it was. And at the time, there were many things that were sort of fuzzy, not star-like that it could have been. It could have been what we now call galaxies. They didn't know what galaxies were. It could have been a planetary nebula of some sort. They didn't know what those were either, but they knew that those sorts of nebulae existed. But Herschel was also a very careful astronomer, a very careful observer. And he put it on his paper, charted out on where all the stars were, and he came back the next day to double check his work and see what was there. And the stars were all where they were supposed to be. And that one fuzzy thing had moved. And that's what you need to know, that this is not a distant star or a distant galaxy or anything else. This is something in our solar system. And it was moving so slowly that even at the time, they knew that it was beyond the orbit of Saturn. But Herschel, I think that Herschel was still not thinking that there was a possibility of a new planet out there. And when he first announced this discovery, it was pretty clear that he thought it was something like a comet. And people knew about comets. They knew that they were fuzzy. They knew that they would go outside the orbit of Saturn sometimes and come back in. So this is what Herschel thought it was. Other people weren't so sure. And eventually, Herschel got convinced to call this thing a new planet. And, new planets get names. Herschel proposed the name George. George, of course, after King George. And who really didn't like that name? Usually when I give this talk here in the United States, people will say, oh, it's the Americans hated it. I don't think the Americans cared. It's the French. The French did not want a planet named after King George. So they complained, and eventually the name Uranus came to be. And it was still not completely clear that this thing was a planet. Like we think of a planet, at the time people thought, okay, a planet is something that is on a circular orbit that always stays outside of Saturn. It's not a comet that comes in. And it had only been, tracked for a couple of months and then a couple of years. And to find its full orbit takes a lot longer than that. This problem was solved in 1820 by French astronomer Alexis Bouvard. He was the director of the observatory in Paris, and he had a lot of other titles, which is, so many that his last title is et cetera, et cetera. That's pretty good. And he wrote this fabulous book called Astronomical Tables, Tables of Jupiter, Saturn, and Uranus. And this book, well, it's full of tables of Jupiter and Saturn and Uranus. It is trying to use gravity and the forces of gravity that each of the planets exert on each other to predict where all the planets are supposed to be. So Jupiter moves along, it's the big bully in the neighborhood. It tugs on the orbit of Saturn, so it moves the orbit of Saturn a little bit. But Saturn's big, so it tugs on the orbit of Jupiter, so they mutually do this. And both of them tug on the orbit of Uranus. And he wanted to be able to mathematically show that everything was where it was supposed to be. And he came up with this theory with a bunch of equations. It's actually not that complicated equations of where Jupiter, Saturn, and now here Uranus is supposed to be. And he had this very nice table of the year and where it was supposed to be. The interesting thing, though, is Uranus was, of course, discovered in 1781, and this was 1820 at the time. So there still had only been 40 years of observation, which was enough to see that it was pretty much going around in a normal orbit. But you still would like to have had more than 40 years. And so Bouvard did the very clever job of going back in time and finding where Uranus was. He did this by finding other astronomers who had gone and made charts of the sky and had accidentally put Uranus down as a star. And he could compare those charts of the sky to what he knew was in the sky. And he's like, hey, that star wasn't there. That was Uranus. And he could do that in 1771. And then he could go back and say, okay, let's go back a couple of years before. Yep, there's Uranus. And he went all the way back to 1690, almost 100 years earlier, was the first recorded observation of Uranus, which is kind of amazing to me. If in 1690, the astronomer could have just made that chart of the sky, gone back a second day, noticed it moved, and could have discovered Uranus 100 years earlier. Kind of amazing. The other amazing thing that Bouvard did is he compared the positions of Uranus to his predictions, his calculations, his theory. And this column shows errors, how far away the observed location of Uranus was from where he said it was supposed to be. And you can see sometimes a little ahead in the orbit, sometimes behind, ahead for a while, behind for a long time, now ahead in the orbit. And Bouvard, you would call him the preeminent theoretical astrophysicist of his day, and I know people who would call themselves the preeminent theoretical astrophysicists of their days today, and they're all the same as Bouvard was back then. And Bouvard basically said, my theory is perfect. Astronomers have been making mistakes. Astronomers need to make better observations. And the astronomers, they felt bad, and they put their heads down and said, okay, preeminent theoretical astrophysicist, we will do better observations. So the astronomers continued for another 20 years, from about 1820 to about 1840, making even better observations. And they realized that even with their very best observations, Bouvard's prediction was still not where Uranus was supposed to be. His theory was wrong. His calculations were wrong, and people understood why. By 1840, everyone pretty much understood why. They understood that there must be another planet beyond Uranus that's also tugging along the position of Uranus and make it sometimes in front and sometimes behind. So 1840, everybody knows this new planet is out there, but people didn't really know how to find it, and nobody wanted to just mount a general search for a planet. And it took another French astronomer at the time, Urbain Le Verrier, who used these very data from Bouvard and used them to make a new theory, very similar to the way Bouvard had done this, but he added in his new theory a new planet, and he could predict the location of where that new planet should be. He sent that prediction to the observatory in Berlin, and they opened up the telescope, and on the very first night of looking, they found it right where it was supposed to be, a degree away from where it was supposed to be, which is, to me, still kind of this shocking story of this prediction, a discrepancy, a new prediction, and then a triumphant discovery in the sky. And I feel like this was the moment when many people, even physicists, realized that this newfangled physics stuff that people were doing, it's not just good for showing how balls roll down inclined planes and for other things. You can actually use it to make predictions about the universe and then go test those predictions and find out they're true. And it really is an astounding moment in the history of science. And in this astounding moment, Le Verrier became very famous. He was described as the astronomer who found a planet at the tip of his pencil. And his name was inscribed on the Eiffel Tower, one of 50 grand people in science whose names are around the tower. He has a statue at the observatory in Paris that looks straight up towards Luxembourg Gardens and the Louvre, and just like very famous. And when he got very famous for finding a planet with the tip of his pencil, other astronomers very quickly said, I want to be famous. I want to find a planet. And they started looking for planets. They started looking for planets everywhere. The first prediction of a new planet right after Le Verrier had predicted Neptune came within months. And the idea was, looking at Uranus and now looking at Neptune, it still looked like maybe the planets weren't quite where they were supposed to be, that there might be something else perturbing them out there.Maybe there's another big planet. So people tried to calculate where this new big planet was. And there were something like, we a couple of years ago, I went and tried to find every prediction of a new planet in the outer solar system since the time of Le Verrier. There have been something like 34 different astronomers predicting different new planets in the solar system since the time of the discovery of Neptune. And I will tell you, all 34 predictions have been wrong, and often for kind of silly reasons. But let's talk about the most famous wrong prediction, and that is, we've heard this name a little bit earlier. This is Percival Lowell. Percival Lowell had predicted that there was a planet beyond Uranus and Neptune. There was a planet, a giant planet, right beyond the orbit of Neptune that was perturbing these things. And he not only predicted that there should be a planet, the first thing he did is he sent a team to the top of Mount Wilson in Southern California. Mount Wilson, I'm literally on the flanks of Mount Wilson. It's actually just right that direction. You could almost see where the telescopes are today if you could see over these trees. He sent a team to the top of Mount Wilson to take a picture of the sky where he predicted this new planet should be, and it looked something like this. And he looked at this picture and he's like, I don't see it. He was looking for something the size of Jupiter. Something the size of Jupiter would be big. It would be a big, big, bright blob there in the middle. He didn't see any big, bright blobs, and so he was disappointed. He kept on working on his calculations. Eventually, he founded the Lowell Observatory in Flagstaff, Arizona. And the goal of the Lowell Observatory was to find this planet that he called Planet X. And the observatory hired Clyde Tombaugh off of a farm in Illinois. And Clyde Tombaugh, whose picture you saw a little earlier from Jerry, Clyde Tombaugh realized that he didn't know what a planet was supposed to look like, but he realized that one key thing about a planet, which is if you see a planet in the sky and you come back a couple of days later and you take a picture of the sky, all those stars or those galaxies are in the same place and the planet moves. And it looks like that. Did you guys see it move? Anybody see it move? No? No? No, you didn't. Let's try again. Here it is the first night. Here it is the next night. Anybody see it? No. No, you didn't. You think you did, but you're wrong. Because here it is the first night. Oh, maybe you did see it. Here it is the second night. Anybody see it? Everybody always sees it the fourth time. I don't know why, but the fourth time is easy. You repeat things enough, it becomes really easy. It's almost like there's a big arrow pointing at it. I'm not sure why. Here's the first night. Here's the second night. These are the actual discovery images of Pluto as you conveniently, you saw them earlier, so you could have memorized the position, but I noticed that Jerry had them at a 90-degree angle to me, so that was good. I'm glad that they were not quite exactly right. These are the discovery of Pluto, and you actually saw the New York Times headline too. 9th planet discovered on edge of solar system, first found in 84 years. So far, good. Lies beyond Neptune? Correct. After 25 years search by the late Percival Lowell, still true. Observatory staff there spots it through special photo telescope, also true. Makes thorough check. Astronomers hail finding, true. The sphere possibly larger than oh, wait, this part's not true. The sphere possibly larger than Jupiter and 4 billion miles away. That part's true. Meets predictions, also true. This is my favorite part of the headline. Possibly larger than Jupiter meets predictions. This is actually a classic case of the way that science can sometimes derail itself. The nice thing about science is it eventually gets itself back on the rails. But here's how the easiest way to make a mistake in science is to predict something, to then find something and assume that it must be what you predicted because it's kind of makes sense. So there was a prediction of a giant planet, possibly larger than Jupiter. Clyde Tombaugh finds something, and therefore it must be that planet, possibly larger than Jupiter. This possibly larger than Jupiter is wrong by a factor of 250,000. That's a lot even for astronomers. You know, astronomers, we're pretty happy if we're within a factor of 10 most of the time. And if you're wrong by a factor of 100, we'll kind of look at you and be like, yeah, that was kind of off. 250,000, that's just not even close to being true. But the only reason, so the reason that Pluto was called a planet to begin with is because people thought it was huge. Let me show you. Let me show you it again. There it is. I can never find it again. But let me show you, instead of showing you it, let me show you how big it really is. Here are all the planets in their real size. You almost never see them at their real size. You always see them, you know, as sort of Jupiter's a little bigger and Mercury's a little bit smaller. It looks nicer on your kid's lunchbox to take to school. But at their real sizes, Jupiter's huge. Jupiter's too big to put on the full screen. Saturn's always shown too small because people want to show the rings too, and that makes it too big. But Saturn's actually quite big. Uranus and Neptune a little bit smaller. Mercury, Venus, Earth, Mars, quite small compared to these big gassy planets. I've even put the biggest asteroids on there. Their Ceres, the biggest one that you saw earlier, and there are about 10 of them that are big enough to be one PowerPoint pixel. So they got to be on there. And I'll put Pluto on there, but you have to look carefully because it's just that little thing down in the corner. It's so small that if you take it away, put it back, it really doesn't change much about what's going on in the solar system. And it really doesn't fit the pattern of what you would think might be the next planet out there. But people didn't know that at the time. They thought it was possibly larger than Jupiter, which is, now look at it again, it's kind of laughable. And so they called it a planet. The other weird thing, if you recall, about Pluto is if you look at the orbits of the planets, here's the terrestrial planets, Jupiter, Saturn, Uranus, Neptune. They're all these nice, beautiful circular orbits. And Pluto has this weird eccentric orbit that goes inside the orbit of Neptune for a while too. It was very strange. Nobody quite knew what to make of it. And even stranger, perhaps, is if you tilt the solar system on its side, you'll see that the planets are all in a nice disk. And Pluto, it's crazy. It's tilted by about 20 degrees compared to the plane of the planets. Nobody quite knew what to make of it, but people thought it was big. There was nothing else out there, so they called it a planet, and it stayed a planet in good standing until about 1992. 1992 was a bad year if you were Pluto. It was a bad year because a second object was discovered outside the orbit of Neptune, and that opened the floodgates. As of today, there are something like 5,000 objects known outside the orbit of Neptune, some of them inside the orbit, just like Pluto goes in and out, and some of them much further away. If you look at the orbits of those objects, it looks like a bird's nest. They are like Pluto. They're tilted one way, they're tilted another way. They are elongated. Sometimes some of them go inside the orbit of Neptune. Some of them don't go inside the orbit of Neptune. It was very clear with these discoveries starting in 1992 that Pluto, it made much more sense to classify Pluto amongst these, of which it's very much a part, than as part of the regular planets. And that's what eventually led to that reclassification of Pluto. And I don't like to think of it as reclassification as much as I like to think of it as correcting a mistake that was made in 1930. If we had known how small Pluto was in 1930 and known about all these other objects in 1930, it would have been really, really obvious that this should not have been called a planet. And so it was just correcting these mistakes, these ways that science sometimes goes off the rails, but then eventually gets itself back on there. The nice thing about this by about 2002, we could look at this part of the solar system and we could show that everything was where it was supposed to be. Remember I told you that astronomers were trying to figure out if there was another planet out there by looking at the orbits of Uranus and Neptune, and they looked a little bit discrepant. Turns out that Alexis Bouvard, back in 1820, when he said astronomers need to do better observations, he was actually correct. Those discrepancies of Uranus and Neptune were actually just bad observations. And as of 2002, it was well known that everything in the solar system could be explained by the things that we knew in the solar system. There was no need to invoke anything else in the solar system. And that was true until 2002. In 2002, we discovered this new object that goes by the name of Sedna. And I will show you its orbit, except it doesn't fit, so I have to make it smaller. Its orbit looks something like this. Sedna takes 10,000 years to go around the sun. And it's on this crazy elongated orbit, and it's crazy. It never even comes close to the rest of the Kuiper belt. This area of all those objects is the Kuiper belt. A very strange thing that I thought I understood back in 2003 when this discovery was made. I thought, okay, this is a leftover remnant from the early stages of the solar system, and we can use it to try to describe how the solar system formed. I was very excited. We went out and looked for more of them, and over time, more objects like Sedna were discovered, and something very strange became apparent. If you look at these objects that are on these Sedna-like orbits, it doesn't take any sophisticated mathematics to see that they're all pointing in this direction, like something is pulling them. And what's weird is even if some weird perturbation happened and they got pulled in that direction at one point, all of the orbits of these types of objects, they do what's called precessing. That means that the direction they point turns with time, and they all precess at different rates. It's almost like they're all hands of a clock that move at different rates. And so if you came back in 100 million years, these would all be pointing in random directions. There's no reason that they should be pointing in this direction. Now, it could be that it's just coincidence, and you can calculate the probability of a coincidence like this occurring, and it is about 1% at the time. And that's, that's not zero, but it's still pretty weird. And so at this point, my colleague and I, Konstantin Batygin, who's just a couple doors down from me and here at Caltech, he and I started thinking, okay, why would these things be perturbed like this? And we both laughed and we said, well, it could be that there's a planet, and like, that's the stupidest idea ever. 34 people have thought about this before. They've always been wrong, and they've always been kind of dumb. And so we're definitely not going to be the 35th and 36th astronomer to make the dumb comment that there's a new planet out there. So we tried thinking about maybe they're massive enough that they kind of keep each other together. Doesn't work. Maybe it's like the Milky Way galaxy is exerting some overall force. Doesn't work. Maybe there's something else. We could find nothing else works. And so in defeat, we really felt defeated at this point. In defeat, we said, well, I guess maybe it's a planet. Let's see if a planet works. Does a planet work? And the answer is, yeah, it works really well. Here's how you figure out if a planet works. One way is you do computer simulations. Here's a computer simulation of, here's the inner, you can barely see. There's the inner solar system right there. That's the orbit of Neptune that you can barely see. This is the orbit of a planet. You won't see the planet itself. You'll just see orbits in this case. And each one of these blue things is what we call a test particle. We started at what we think of as the beginning of the solar system, and we started a lot of objects on these very strange circular orbits, and just decided to see what's going to happen. So let's see what's going to happen. This takes about 4 billion years, so I hope you have your tea with you. Very quickly, what happens is this planet starts to clear the orbit. All those things that are gone now are because they came too close to the planet. They crossed the orbit of a giant planet, and crossing the orbit of a giant planet is bad news. You can see that when they sorry, I have my cat wants to sit on my lap as I give this talk. Everybody say hi to Rosie. You can see that as they get, particularly over here, they get close to the planet's orbit and they go away. The ones that don't go away, or they don't go away as quickly, are the ones that are over here. And the reason is because even though you're crossing the orbit of the planet over here multiple times, you're doing it very fast. Orbits spend most of their time on the outer parts, and then they travel fast through the inner parts. So they're safer when they're out here, and they quickly go through here. The planet does the same thing. So the planet is more often out here. These objects are more often out here, and then they quickly go through there and they're safe. So in the end, after 4 billion years of this, you have a set of objects on the inside that were largely unaffected. And on the outside, you have the last stragglers. And you can look, and it really is the last stragglers. There were a lot of objects to begin with, and not very many left over now. And that is how...
Mike,
Yeah.
so to interrupt, have you stopped sharing your screen?
I have not. Does anybody else not see it?
I can see it.
Really?
Yeah,
Very
I got it.
strange.
I can see it too, so no problem here.
Okay, it's fine.
Okay, so you can see how this planet will make this. And so when we see in the sky a pattern that looks like this, which is what we see, we are seeing a pattern that could have been made by a planet on an orbit like this. So we did these simulations. We did a lot of these simulations. They all worked out pretty well. And we were like, well, I guess we can write a paper and say, maybe there's a planet out there. But it just felt embarrassing to jump up and down and say there's a new planet out there. So we decided that we had to make we couldn't just say there's a planet. We had to have a prediction. We had to have something that we could predict and then find and then really convince ourselves that there was a planet. And one interesting thing that we predicted and didn't find, and this was enough to make us pause also, is that in addition to these planets making objects like this, one of the things that you couldn't see on that last simulation, but happens, is that when these objects are being removed, scattered away from the solar system, they do it in a very peculiar manner. Their orbit will twist sideways. And so instead of going this way, they'll twist down or twist up, but they'll also twist to be perpendicular to the solar system. So they will be plunging into and out of the plane of the solar system on their way out of being removed from the solar system. And we didn't know about any objects like this, and they had to be there. There was no way to hide them. They had to be there. And so we were scratching our heads and thinking that we had this whole idea wrong and didn't know what to do. And then I realized that I had neglected to look at one entire data set that I could have. And in that data set, there were objects just like we were looking for that were on these orbits, very long orbits. They are perpendicular to the plane of the solar system. I didn't know where they were pointed yet. And so I called Constantine into my office. I'm like, okay, man, we're going to look. We're going to see. They're either going to be on these nice wings right above and below this cluster, or we're wrong. And the answer is, here they are. They are beautifully placed on these wings, just like we predicted that they were supposed to be, in and out of the plane of the solar system and perpendicular to this cluster we see there. And Constantine and I looked at these plots, and I think our jaws just dropped to the floor at this point. And in our heads, this is the moment it went from this cute idea that could explain these things, ha ha, but we don't really believe there's a planet, to, oh, there's actually a planet out there in the outer part of the solar system waiting to be seen. And this is when we wrote this paper, and we confidently predicted, this was 8 years ago, confidently predicted that we would find this planet within 2 years. And every year since then, I've said 2 years. And Constantine said 10 years. His 10 years and my 2 years are now coinciding. So I think it's going to be true. I think we really will find it within 2 years. I'll show you why. But first off, I want to show you some other predictions. The obvious other prediction to make is that there'll be more of these things in this direction. And we, made that prediction, but that's a pretty obvious one. These are hard to find. In these 8 years that we've been looking for objects like this, a few more have been found. And here they are. They are these new bright red ones are the new ones that have been found, and one white one in the wrong direction. The one in the wrong direction is actually good, because our understanding of how the physics of this works now suggests that there should be a small number over here too. And so until this one was found, I was getting worried that we weren't finding enough over here. But now this is still perfectly in line with the predictions. And there are 3 or 4 other dynamical predictions that we've been able to make over the last couple of years. They all turn out to be exactly correct. And I think at this point, it is very difficult for me to imagine how the solar system can have put itself together and do the things it's doing right now without there being another. If you hear strange sounds, that's my cat making weird noises down behind me. She's snoring as she's asleep in my lap. Yeah. So it's hard to imagine how you could put the solar system there and make it look like it does without there being a new planet. So I know it's weird. I said that like 34 astronomers before us were wrong and kind of dumb, but you should believe us because we're right and everybody else was wrong. But in my defense, you should believe us because we're right and everybody else was wrong. That's my argument. I think there really is a planet out there, and I think we really need to go find it. And I think we are going to find it in the next couple of years. Let me tell you a few more things about it, and I'll tell you how we know the things that we know about it. The other thing we know, besides kind of what kind of orbit it has, we know about how big it is. And in our very first paper that we wrote, we had done sort of a limited number of computer simulations. The way we figure out how big it is we do those computer simulations just like you saw, and we adjust all the parameters. We make the planet a little more massive, a little less massive. We make the orbit a little more distant, a little closer, a more tilted, less tilted. All these parameters we change, and we see what matches best. And now the best match is actually, instead of 10 Earth masses, it's like 7. So Planet 9 is in this really interesting mass range midway between Neptune and Uranus, which are 17 and 14 and a half times the mass of the Earth, and the Earth, which is exactly 1 times the mass of the Earth. Planet 9 is about 7, maybe 8 or 9, 7, 8, 9 times the mass of the Earth. And what I have for many years taught this class on the solar system and how it relates to other planetary systems that we know in the galaxy. And for many years, I would say, isn't it weird that in our solar system, we jump from the Earth to Uranus and Neptune, and we don't have anything in between? In other stars in our galaxies, something like a planet with 10 times the mass of the Earth, 5 to 10 times the mass of the Earth, it is the most common mass of a planet that we find in the galaxy. And it was weird we didn't have one. And the answer is we have one. So we have one of the types of planets that appears to be the most common. And now we just need to go find it. Okay, so let's, for fun, show us how it fits on this slide. Before I show how it fits on this slide, I want to see, I filled in more of these objects in the Kuiper Belt. There was Pluto, which is still the largest by like that big. I was so mad, when Eris, when we finally got its size measured precisely, it was still, we thought, bigger than Pluto with that precise size measurement. And then when New Horizons went to Pluto, it grew by just a little bit. I think Pluto did it on purpose just to be big. But actually Pluto is 25% less massive than Eris. So Eris is still the most massive, and mass is what matters. Don't let any speaker like next week tell you that it's the biggest one. It's the more massive one that matters. And Eris is more massive than Pluto by the mass of the entire asteroid belt. If you took Pluto and you added every single asteroid that we know, you would get Eris. So it's a lot more massive. You can also see fun objects like Haumea. It's the weird shaped one. There is who is that? That's probably Makemake. There's Quaoar. There's Orcus. All kinds of my favorite little babies are in there. But Planet 9, how big is Planet 9? Is it, just a little bigger than Pluto? Let's argue about whether it's a planet or not. No, it's huge. Planet 9 is the 5th largest planet of our solar system. And what's nice, I think, it's what you would expect the next planet to look like. It's not just a little ice ball like these other things. It's something that fits within the category of all these other planets. So let's go find it. How are we going to go find it? Well, we actually know a good bit about where to look, and we know a good bit about where to look because of these computer simulations we've done, where we've tilted the orbit this way and tilted it this way and made it bigger and make it closer. That gives us the orbit of Planet 9, or at least statistically where it might be. What it doesn't give us, and I'm sad about this one, because it means I don't get to be on the Eiffel Tower like Leverrier. It doesn't give us a position of Planet 9 within its orbit. It only tells us what the orbit is like. And so it's interesting to think, why could Leverrier way back then get a position of Neptune and we can't do it now? The reason he could get a position of Neptune is because he had Uranus, and he had 150 years worth of Uranus data. So Uranus had taken 2 orbits around the sun, and Leverrier could watch as Uranus was being tugged by Neptune in all these various positions, and he could then essentially triangulate where it was. We can't do that. We've seen these objects. These objects that are being affected by Planet 9 have 5,000-year orbits, 10,000-year orbits, and we've seen them for a decade, maybe, if we're lucky. So we can find the orbit, but we can't find the position in the orbit. If you give me 5,000 years to track these things, I will be able to point exactly where Planet 9 is. I'm hoping we don't have to take 5,000 years, because I think I know how we're going to find it. But here's where we predict it is. So this is a map of the sky, full map of the sky. The equator is the celestial equator. The ecliptic, where all the planets are, is this nice line right through here. And this funny shaped line is the Milky Way galaxy, the southern Milky Way galaxy down here, Sagittarius. Northern Milky Way galaxy is up in here. And the color is the probability distribution of where we think Planet 9 is. Red means highest probabilities, lighter green, lowest probabilities, dark blue, no chance. And you can see that the highest probabilities are up here in the northern hemisphere. In the Milky Way galaxy, that's irritating. That makes it harder to find. And sort of in the region where the Milky Way galaxy, the ecliptic goes through the Milky Way galaxy. Notice, though, that Planet 9 is tilted. It's not in the ecliptic like the other planets. And you could even have seen that just in those very distant objects that had their elongated orbits. They're all tilted by about 20 degrees. Planet 9 looks to be tilted also by about 20 degrees. And it's more likely here because in its elongated orbit, this is its most distant region, and that's where it's most likely to be. Okay, we can predict where it's likely to be. We can predict how far away. That comes from these same computer simulations. So it is most likely at this range of about 400 or 500 AU. So I'll remind you, AU is the distance from the Earth to the Sun. Neptune, the currently most distant known planet, is 30 AU. So we're talking 15, 20 times further away than Neptune. This is not that thing that Percival Lowell was looking for just outside the orbit of Uranus and Neptune, perturbing Neptune. This is so far away that, yeah, it does perturb the orbit of Uranus and Neptune, but not by any currently measurable amount. So the only way to see where it is by looking at the orbits of these objects that go out much further than that. The one other thing we can predict, which is fun, is how bright it is. And that requires some assumptions. To know how bright it is, you have to know how big it is and how reflective it is. And we don't know either one of those things, but we can make a range of assumptions. The first assumption is what kind of planet it is. In this picture that I showed you back here, at this size, and I drew it purposefully as white, this is what it would be like if it was a scaled down version of Uranus and Neptune. Uranus and Neptune are large icy cores surrounded by big, thick hydrogen and helium envelope. If Planet 9 was like that, it would be about this size. That size is about 2 times the radius of the Earth. And it would be very reflective because it's so cold out there that any of the clouds or any of the materials that would absorb in the upper atmosphere would have all gone frozen out and gone down below. And so it would mostly just be reflecting the sunlight there. So that would be the brightest it could possibly be. It could also be, you could imagine, instead of being a gas giant planet, maybe it's a giant ice ball, like a scaled up version of Ganymede or something like that, scaled up version of Eris, scaled up version of Triton. These things would be smaller because they would be denser, and they would probably not be as reflective. And so that's kind of the smallest version that you could see. They would still be bigger than the Earth. They might be like 1.5 times. Maybe they would be this type, this size, and a little darker, a little dirtier. So we take that full range of our ignorance and fold that into where it might possibly be and come up with how bright it might possibly be. This is in magnitudes, and many of you are familiar with magnitudes. In case there's any who not, just remember that the larger the magnitude, the fainter it is. We can blame the Greeks for that. That's their fault. And if you don't immediately have your brain calibrated to how bright any of these things are, let me say that something that is down in this very brightest range, you could see in good backyard telescopes. I'm sure there are people on this call who have imaged things as bright as 19th magnitude, 20th magnitude, not even that hard. If it were that bright, we would have found it already. It's not that bright. So we can rule out this little slice down here, which is mostly this region where it's close in and in the southern hemisphere. A little bit fainter is in the range of maybe 100 modest sized telescopes around the world in this 21, 22 magnitude range that you could routinely see things that are that faint. And that's sort of maybe it's most likely. If you get out to 23rd, 24th magnitude, you're down to the tens of the largest telescopes, but you can still do it. If you're down beyond there, like if you're 24th, you need a pretty big telescope. There's just a few large telescopes that will routinely get to be able to survey areas like that. And if you're in the very faint end, it's really hard. If it's 26th magnitude, 27th magnitude, you need, I don't know, a Hubble or a James Webb or spend a lot of time on a really big telescope. So this is, not terrible news. And the way the way you would search for something like this is you could try going to the telescope. You could try getting a big telescope, a few of the large telescopes. You could apply for time on a big telescope, and you and every other astronomer in the world wants time on that telescope. So you get a couple of nights on that telescope. You take some images of the sky. You come back the next night. You take some images of the sky, and you survey a pretty small region because you don't get that much time. We've done that. We've covered a pretty small region in through here with the giant Subaru telescope on the summit of Mauna Kea. It's not a great way to do it. A great way to do it is to get a dedicated telescope that is looking at the sky night after night after night, just taking images, looking for things that change. And there are a couple of those. There's one down here in Southern California that's run out of the Palomar Observatory. They call it the Zwicky Transient Facility. It's looking for transients, things that move. And it's in this range of 100 modest sized telescopes. And it has basically ruled out anything that is about 20th magnitude. There's another one on the summit of Haleakala on the island of Maui in Hawaii. That's called the Pan-STAR survey, and it's gotten to about 21st magnitude. So we've ruled out almost all of the southern hemisphere here and all of the sort of bright objects here. What we really need is a big telescope. We need to combine these things. We need a really large telescope, and we need it dedicated to looking at the sky night after night after night and looking for things that move. So what I really want, if you were to hand me £1 billion, which I highly recommend, I would then hand it back to you because I don't actually need it, because they actually have just built this telescope and they didn't even do it for me. This telescope exists and it is just about to start operations in Chile. This is the Vera Rubin Observatory. And the Vera Rubin Observatory, you can see it's a big telescope down there. It's got a huge mirror and an even more huge camera that is attached to that telescope. So it is designed to image the sky night after night after night. The camera covers so much sky that it can cover the entire sky in about 3 nights. In the early part of the 2000s, when we were discovering Eris and Quaoar and Makemake and Haumea and any of these other dwarf planets you might have heard of, we were doing the same thing. We had the biggest camera on a telescope at the time, and we were trying to cover the whole sky and come back and cover it again. It took us about 2 years to cover the whole sky. It takes this telescope 3 nights, then it goes back and does it again. It's just astounding. And I think even more astounding, it covers the whole sky night after night after night. It will automatically compare, when you take a picture of the sky, it will automatically compare the last time or the last many times that it took an area of that sky and very quickly find all the things that change. It will find things that change, like stars that got brighter, supernovae that exploded. Every time anything in the solar system is there. It's always changing. So an asteroid was here one night and it's here one night. Those are changes. So it will report all of those tens of millions of changes every night, and it reports them within 60 seconds of having taken the image in the sky. And it is open to everybody around the world. It reports them to an open web system. You can go and search for everything that you might possibly want to search for. And this telescope begins operations tomorrow. I actually literally don't know when it starts, but it might start next week. It was supposed to have started, well, like everything, it was supposed to have started 5 years ago, but it really is sometime in the next couple of weeks. They're going to start the survey and we're going to start getting data. And I think that at this point, we will find this planet. So we will either find this planet with these data. It is possible, I will go back to here, this is going to be, it's going to get down to about 24th magnitude. So there is a chance that it's further away and too faint even for Vera Rubin, and that would be depressing. But the good news is, even if we don't find Planet 9 in Vera Rubin, we will continue to find more and more of these objects in the outer solar system that point towards it, and we will know a lot more about where it is and how to find it, even if we don't find it. I think, though, fingers crossed, that we're just going to find it. That's my goal. Within the next 2 years, I think we will have Planet 9 in the bag. And the only thing we're waiting for is this telescope to turn on and for the data to start to get good enough that we can start to do these analyses. So I have my calendar cleared literally for the next year, just waiting for these data to start rolling in. And I can't wait to find it, or somebody else can find it. The data are totally public. Anybody can go look. Everybody should go look. Anybody might find it and be kind of fun. I hope to find it, but if somebody else finds it, that's fun too. So I just want to end this talk where we started. I want to end first with where in the sky Planet 9 is right now. I think if you go back and look here, I think it's going to be up in here. This northern Milky Way, right up in this section here. And that is my favorite spot in the sky and everybody's favorite spot in the sky. It's kind of this region between Orion and Taurus. The orbit of Planet 9 goes right between these things. And you can see, here's the Milky Way. You can see how many more stars are up in here and how much harder it is to find things because of it. But still, what a fabulous spot in the sky. And that, this spot in the sky, if you're out late or if you're up early, you can see Orion sitting there in the sky. And every time I see it these days, I just sort of stare and I think about, Planet 9 sitting right on top of Orion's head, waiting to be found. And I think this is the year that we're going to do it, in the next couple of years. And I have said that every year for the past 8 years, but this time I mean it. I always mean it, but this time I think it's true. We have the way to do it. So again, I want to really end with where we started, and I'm sure many of you recognize that we ripped off this poster directly from the Plan 9 from Outer Space movie, and it's an appropriate movie to have ripped off. Of course, it's called widely famous as the worst movie ever made. It was voted by some directors guild as the worst movie ever made. It was directed by Ed Wood, who's sort of this weird genius director, and it is a truly terrible movie. It includes posthumous scenes of Bela Lugosi. It includes Vampira. It includes, this is actually Konstantin Batygin before he was born. They actually put him in there. He looks about like that. But my favorite part of this movie is the graveyard scene. They're digging up these zombies who are, I can't remember. It's so bad that it's hard to even remember what the plot is. But here they are in the graveyard. So this movie was from 1959. And I just want to put it in context. 1959, it was about 29 years after the discovery of Pluto. Pluto is still a planet in good standing, but Ed Wood, the misunderstood genius that he was, I think knew something about Pluto at the time. So if you look at this graveyard scene and you zoom in right here, even on the poster, you can really see that Ed Wood knew that this was Pluto's time was coming, and it was coming soon. And with that, thanks for coming. Thanks for listening to my stories about what's going on in the outer solar system. And I am happy to take some questions, and I think we're doing them off the chat. is the plan.
Yeah, we've already got some questions in the chat. Thank you so much. I'm a believer now. I'm totally sold on this. So definitely. But good first question here. Could it be, rather than being planet 9, could it be a small black hole rather than a planet? And that's why you can't see it. That's from Pete and M.
So the answer is yes. So everything we know about the planet is just from gravity, just from its mass. And so if you put a 7 Earth mass black hole there, it would do the same thing. Also, if you put a 7 Earth mass burrito or a 7 Earth mass house cat, they would all behave, well, the cat might not behave the same way, but the gravity would be the same. So from the gravity, you can't say anything about what it is. But one of the things you can do is then start to see which of those makes sense and which doesn't. So burrito probably doesn't make sense. Cat, okay, unlikely. Black hole, probably unlikely for this, in the sense that a planet, there's no particular reason not to think that it's a planet. And here's the reason why. We see planets like that around other stars. A planet is actually a pretty mundane explanation. Like we know that stars have planets on these distant eccentric orbits like this. We have ideas on how those planets can get there. There's no need to invoke some exotic explanation when a mundane one works. Does that mean it's true? No, it doesn't mean it's true, but it means that scientifically we're gonna go with the mundane thing instead of the more exotic thing until we've ruled out the mundane idea. And so I'm pretty sure it's a planet, and we don't need to have a black hole out there, but we will know once we find it. If we find it, we'll know the answer.
Thank you. I've got a question from Kevin Taylor, which is, how can planet X, at only 7 times the mass of Earth, exert such an effect over these huge distances? Yeah,
so one, it's not planet X. We have to get this straight. It is planet 9. Planet X is the name that Percival Lowell had for his planet that he was predicting. And so people have sort of lost that historic reference of what planet X really is. And so now people tend to call planet X as anything out there. It really shouldn't be. The planet X we should keep as the idea that there was a massive thing right outside of Uranus and Neptune. And this one's planet 9. So how does it exert such a dramatic influence? Well, I think you saw that in those computer simulations. One is it does it over very long periods of time. It took 4 billion years before that pattern really exerted itself. And the way that it does it is mostly by having close encounters with these objects and then having them removed from the solar system. So it's really just carving out. It's that process of clearing the neighborhood that was talked about as one of the criteria for planet. It clears its neighborhood because even though it's really far away, the objects that it's clearing are also really far away from the sun. So they're pretty loosely held by the sun. And so it can clear those out fairly efficiently over really long periods of time. It takes a long time to do it, though.
Thank you. Next question from Louise Franklin. Why is planet 9's orbit so different from the other planets?
Oh, yeah. Great question. So it tells you something about how it got there. And since when we first had the idea that planet 9 was there, our favorite hypothesis for how it got there is that it actually formed in the region of Uranus and Neptune, and that's why it's maybe like Uranus and Neptune, and then it got too close to one of them. When it gets too close, it can get scattered onto one of those very distant orbits, and then it's basically been lurking out there in the outer solar system ever since there. A few more things have to happen, but that's the basic part of the story. It gets scattered out there by one of the planets. It's not the only hypothesis. I think it's a good one, and there have been recent papers that really have shown that this idea works quite well. Another idea that has been proposed is that we actually stole it. We stole it from another star. That star came by, had a planet around it, and it got too close to the sun. The sun's gravity grabbed that planet. The star kept on going, and it left it in that big crazy extended orbit. That's a possibility. I think it's a less likely possibility. But the fun thing is, when we find Planet 9, we will get to study it, see what it's made out of, see what kind of planet it is, and that'll give us some ideas about how it got to be there too.
Okay, the next question is from me, which is, are there educational resources to help get the public excited about the hunt for Planet 9 during this time when waiting for it to be discovered?
Oh, that's a good question. I don't actually know the answer to that. We haven't really done any because we're too busy trying to find it. And I don't actually know. There should be.
If you've got any funding, I'll help you.
That's yeah. It would be nice to have them. Definitely true.
I think we should do something in the UK. We've got some networks that help coordinate things like this, and I think it's something we should look at for sure.
Yeah, that'd be really cool.
So the next question is from Kevin Taylor. If Rubin is in the southern hemisphere, does this limit its ability to view the most likely location of Planet 9 in the northern celestial hemisphere?
Yeah, big pain, right? So let me go back to my picture. And it is absolutely true that we wish that Vera Rubin was in the northern hemisphere and could cover this region really well. The good news is, because one of the things that Vera Rubin is very interested in is finding asteroids and potentially hazardous asteroids and all that stuff, it is going to look all through the ecliptic and a little bit north of the ecliptic. And so it's planning on doing this whole region. There's a little bit right up in here that it's not going to do, but that's a pretty small area of where we think Planet 9 is going to do. But it's still going to do a very good search in through here. It'll be low in the sky. It'll be pointing pretty close to the northern horizon when it does this, and so the data won't be as good, but it'll be good enough. I'm excited. I think we'll be getting those data sometime soon, I hope.
And there was one more question. It's also from me, which was: were there any predictions of planets before Neptune, or was that the first time someone tried to predict one?
Oh, no. So from the moment of the idea that from the discovery of Uranus, before Neptune. Wait a minute. Let me think about this. Were there any before Neptune? I was about to answer the wrong question. I don't think so. I don't think so. It's a good question, and I'm not sure. When I was looking pre-1781, I didn't see anything, and now I can't remember whether I actually looked in that time period. I do know that as I said, around 1840, it was widely understood that a planet was the most likely explanation for the anomalies of the orbit of Uranus. But I don't know, how those ideas kind of percolated. It'd be a good one to look into. That'd be kind of fun.
So has anyone else got any questions they want to throw in the chat, or just speak up? Oh, there's one more. So Steve Bosley asks, do your simulations that predict objects ejected from the solar system suggest any limits to the number of extrasolar objects like 3I Atlas?
Yeah, that's a great question. So things like Atlas are from this exact process. It looks like a comet. It was probably somebody else's comet that got ejected from a process like this. The process that you saw in our simulations is actually probably not the most important one for ejecting the most mass. The most mass is ejected from the giant planet region directly, not these. Even though it looked like a lot, that was a probably relatively small amount of material compared to everything else out there. But there are very nice simulations of the cleaning out of our own outer solar system of probably something like 35 Earth masses worth of material. And so that's when we're looking at that and we're trying to come up with how often do these interstellar comets come through, those are where you try to put those numbers together. And there are people doing that. I don't know how those are fitting together right now. I haven't paid as much attention to that, but it's those sorts of simulations that are doing it.
And we have another question from Kevin Taylor asking, would Vulcan be included as a failed planet search?
Yeah, yeah.
think
So
it was
I
called
love
Mercury.
the cautionary tale of Vulcan. So Vulcan, no one, a rare talk, no one has asked me what we're going to name Planet Nine, and so I didn't get the chance to give my standard answer, which is we are not going to think about a name. We don't think about names until we discover them because we're superstitious, and one of our strongly held superstitions is if you name it before you discover it, you'll never discover it. And the prime example is the planet Vulcan, which was never discovered because it doesn't exist. So planet Vulcan, as many of you will recall, was actually Leverrier. Again, Leverrier both correctly predicted Neptune and then incorrectly predicted Vulcan. So Vulcan was predicted to explain the precession of the perihelion of Mercury, which was precessing too quickly. We now know, of course, that that's due to general relativity and one of the big predictions of Einstein. But it was Leverrier's math was exactly right. If there were no general relativity, and if you didn't know about it at the time, which he didn't, a planet would have done it exactly right. And so he predicted it, he named it, people look for it. He never found it. The other thing sometimes people ask me about Vulcan is like, well, what if instead of Planet Nine, it's like Vulcan and there's no planet, but it's some other physics that we haven't discovered. Wouldn't that be embarrassing to you? And I'm like, dude, if this points to new physics instead of a planet, that's actually an even better thing to have pointed to. So I would be astounded and amazed and delighted. So far, nobody's come up with any good new physics that could explain this, but you never know. Hoping to do it. So Vulcan is a great can of worms to explain a lot of things about what's going on in the discoveries of planets.
There's a question I'd like to ask. You talked about Vera Rubin and how its view for this area will be fairly low on its horizon. The James Webb Space Telescope is more infrared rather than visible light.
Yeah.
And obviously infrared from something that far out is going to be very, very low. But is there any work that it could do?
So James Webb Space Telescope is not a telescope that's designed to do surveys of big areas of the sky and search for, the one planet that's out there. It takes pictures of the sky that are about this big, maybe if you can see that big, but with exquisite sensitivity. So the faintest objects in the Kuiper belt that James Webb has currently discovered, I showed you that plot and I said, if it's beyond 25th or 26th, it's really hard. The faintest things that James Webb has been able to see are about 30th magnitude, which is an insanely faint object. I think in the Kuiper belt, that puts you down to maybe a kilometer across or something like that. So it's really good for finding some very, very far away, very faint things to learn about other processes, but you're never going to use it to scan a big area of the sky.
So if we find it with Vera Rubin, for example, then James Webb could be more detailed.
So there are, as I said, once we find it, probably every telescope that we can get our grubby little fingers on, we're going to be able to try to use. So James Webb will be great for understanding what the atmosphere is, what it's made out of. We'll want to use the Hubble Space Telescope to see if it has moons around it that we could then use to watch how long they take to go around it, figure out the mass, moons and rings maybe. Maybe we'll be able to see clouds in rotation. Giant radio telescopes like the ALMA radio telescope in the Southern Hemisphere will show us how much heat is coming from it, which will tell us something about its interior structure. So there's so many things that we want to do, like the day that we find it, we'll start trying to do these things too. It'll be very exciting.
And on that, can you imagine how people felt back in 1930 when Pluto was discovered?
Yeah.
It's going to be quite something for us, hopefully within the next couple of years, to be able to say, yes, I was alive when the next main planet was discovered in our solar system.
Yeah. It's going to be fun. I really hope that Vera Rubin is the one that does it, and that I don't have to wait another more than 2 years because I'm ready.
That's fantastic. Thank you so much, Mike. That was a fantastic talk, very inspiring. And I think we're probably all now excited for what the science you'll be able to do when you do actually track this thing down. I know it is now 7:30, and I know you do have many other important things you need to be doing as well. So thank you so much for giving us your time. And I think people can't clap very easily. You could unmute yourself and clap maybe, because it's great. Thank you very much.
I like the ones on the screen. Those are great.
Yeah.
Thank you, though. This is a lot of fun. Thanks for all the good questions too.
Thanks ever so much. Mike.
Thank you indeed. As I said in the introduction, that you are the person really to talk about this subject, and we're so grateful that you've given up your time to do so. It's been quite a scoop for us.
Well, my cat is mad at me because I was too loud, so she ran away.
Thank you very, very much indeed. And if I just share my screen again, nope, not that one. Yeah. So let's just move that out of the way. So this is the first of two important webinars that we are arranging. The next one is in 3 weeks' time, where we will have Alan Stern, who was the proposer and the principal investigator for the New Horizons mission, which flew past Pluto 10 years ago, and that's what actually set all this up. This year is the 10th anniversary of that. So he'll be talking to us from Colorado. So by then we'll be on GMT. So it'll be 5 p.m. for us, and again 10 p.m. for him, although he's in a different time zone from Mike. So if you go to the FAS website, you can follow the links and book tickets for that. If you are a member of an FAS member society, then you get them at half price. And we look forward to seeing you then. So thanks very much indeed for being with us today. And we look forward to seeing many of you again in 3 weeks' time. Okay. So if any of you want to stay on and chat, then you're welcome to do so.